So our next speaker, Randy Oliver, and he'll be speaking to a test of summer mite treatments. Randy, take it away. Thank you.
Sorry, I had to stop sharing my screen.
Okay. From beginning. Okie doke. You got a big yellow screen up?
Yes.
Okay. Hey, so Steve, I'll leave my video on right now. If my voice starts to break up or something, let me know and I'll turn my video off and get more bandwidth, okay?
Will do.
Okay, I'll let you let me know. Okie doke. So let's get going on this here. One, I hear that you guys have had some fires up there. These are midday conditions. Right now, looking out the window, we have very, very smoky air conditions yet again today. And my wife's choking and everything. It gets pretty ugly. Another one, this is smoke from the fire. Middle of the day, when suddenly a dark cloud came over and I had no idea whether the smoke was coming from just over the hillside or from far away, and it ran away from the yard to get a look. But it's been scary here. The other thing is, you know, I need field technicians doing work. I'm running several trials this year. And my grandson, Ryder, was with Zoom for school. He had the day free. And so this is the new field technician in training, doing a really good job of recording data and doing quality control when we're out in the field to make sure that every treatment, this is a probiotic treatment that we're putting onto hives, actually gets given to the right hive and get all the hive numbers straight. So let's get on to Varroa management. We're all beekeepers, and we do our best to understand bees, and the better you understand bee biology and population dynamics, the better a beekeeper you are. But we're also all Varroa keepers, and being a Varroa keeper, I should say, some of us actually turn out to be better Varroa keepers than we do beekeepers. Essentially, we spend most of our time just rearing Varroa food. When you shift away from just rearing Varroa food, you can become a better beekeeper. So that means that we should understand the Varroa population dynamics and monitoring methods, as well as we understand our honeybees and understand what kind of ways you can suppress the reproduction of Varroa by treatment or by other management methods at different windows throughout the year, and also the side effects of the different kinds of treatments. So the thing to keep in mind is anytime a colony is rearing brood, that mites can reproduce. The other main thing is that if you're using an alcohol wash or a detergent wash, it will underestimate greatly the amount of mites that are building up in the colony. This is where you can pull out this model and show, like I did with Ramesh's data yesterday, when he showed the percentage of mice that they found in the brood. And so I quick checked my model against his and came up with exactly the same percentage showing in the brood. So I'm happy when I get hard field data to validate the model here. So you can, on the model anytime, it'll show you what percentage of mites are in the brood. I showed you this slide yesterday about how as Varroa prevalence goes up, also the prevalence of infected bees with the viruses goes up, especially with deformed wing virus. Now here's something a little different here. What I'm showing here is the rate of increase of the mite and the bee population at each time point. So these are all 15-day time points throughout the year. This is the Varroa rate of increase, and this is the honeybee rate of increase. Now, the reason I'm doing this is you'll often hear, oh, well, the honeybees get ahead of Varroa in the spring, and the Varroa catches up later. And what this shows is that's absolutely a misconception, that the Varroa mites take off in the spring with a higher rate of increase than the honeybees, and they maintain a higher rate of increase throughout the entire year until the bees stop rearing brood. So Varroa gets out of the gate first and stays ahead of the bees the entire time. Now, if there's no increase or decrease during a time period, that these two plots here would be right along this blue line. That'd be no change at all. So you can see during there's periods of the years where the bee population is going down, and there's periods where it goes up fairly rapidly. But the Varroa is always outpacing them. For most environments, with a winter, not down here in California, the most rapid rate of Varroa increase is during the spring when there's colonies are just getting ready to swarm and there's lots of drone brood inside the colony. So you will see that here. On the other hand, in California, where we, or anybody who's going to almond pollination, that gets shifted way forward. When you take your bees into almonds, suddenly Varroa just starts exploding early on. So it starts you off with a larger population of mites earlier in the spring. So almond pollinators are a whole different situation than Joe beekeeper who does not go to almonds, because we get our bees kicked into gear, and Varroa kicks into gear much earlier in the season. And here's the thing to look at here. And I plotted this out. This is not the total Varroa population. This is the additional Varroa in the population of the hive added for each 15-day period. To get total population, you would add every column to the left of any point and stack them all on top of each other. But it shows that because the population increase in Varroa is a function of the starting population in that time period by a exponential multiple, that the larger the population of Varroa, the more total additional mites you get per time period. So in May, you're only getting an extra maybe 200 mites in the colony. So you're going from whatever you started with to 200 additional mites at the end of that time period. You get out here to September, now you're getting over 1,500 mites additional in that same time period. So at this point, Varroa just gets out of control because it's just increasing so fast. If, on the other hand, you did a treatment on May 1st and reduced the mite population by 80%, the mites never can catch up and increase very fast throughout the rest of the season. So the key thing is that we found in our management is you get those mites down early in the season, and it's much easier to manage them for the rest of the season. Many beekeepers wait until it's too late to start thinking about Varroa management. Now, this means that you may have to treat for Varroa while there's supers on, or while there's nectar coming into the hive. And here's a picture of a typical mite increase. This would be pretty close to what I would see in my area if we started with small colonies in the spring. And you could do a late treatment here. You could drop the mite population down to alcohol wash of 0, and it's too late because you've already got this huge virus epidemic going on in the hive at this time. Oh, my computer restarted last night and lost the PowerPoint, and I guess I went back to an old version. So I will have to revise this one. So I'm sorry for that. So here's this critical window often of reducing the Varroa population before it builds up, which often occurs while people have honey on the hive. Now, these are the available treatments that we have right now, and each one has temperature restrictions or honey restrictions. You have to stop with Apivar, remove the strips 2 weeks before you start putting on honey, and it takes about 6 weeks to treat. So limited right here. The two that can be used here are formic acid and HopGuard currently. There's another one here, and if you might have seen this on the internet, Forbes magazine made this an article on the high school student, Raina Jane, who actually patented this device to put in front of the hive and impregnate it with thymol and catch the bees going in and out and try to get the thymol concentration up on their bodies enough to have effects upon the mites. So Raina contacted me, and we just started this trial. I just started this trial about 2 weeks ago on a number of my hives, where I put her device on there and training the bees to go through these devices. I had her make me some control ones also that did not have thymol, so I can compare the two of them. I'm going out every day and taking sticky board counts for mite drop of all these. Start with baseline counts, then I want to see whether it increases the amount of mite drop. And one of the things that we learned, I took this picture yesterday after I spoke, and you can see that the bees, even after a few days, really don't like sticking their heads into these thymol impregnated tubes to go through. They'll do it, but they'll look for any other crack in the hive to get in and out rather than going through the thymol entrances. So we'll see how that works in the long term. Another one, we spoke about this also yesterday, the thermal treatment. And there's been a number of papers, especially in Europe, published about this. And the point is, when you get the temperature of the brood chamber up to above 104 degrees Fahrenheit, you go fairly high, 116 for a while, and hold it for a period of 2.5 hours. They say mortality of the mites in the sealed brood is virtually absolute. Now that's a really strong statement right there. Whereas the bee brood withstands this temperature unharmed. So I was curious about this. I've heard about formal treatment, so I thought I'd do a little quick and dirty experiment myself. And I checked with some other beekeepers who have used it, because there's some glowing reports. And Mike Immer here sent me, he has a whole blog on the web about this and showing the graphs of the Varroa reduction. These are mite counts here, just dropping down close to 0 right here on his treated colonies. And I had every reason to believe everything he spoke to me about this. So I tried a small trial myself, and I'm intentionally blotting out the device I use, because I'm not interested in the device. I'm interested in just the getting actual data of what happens. And what I saw is when we do the thermal treatment, and I did them at temperatures, around 90 degrees up to maybe 95 ambient temperature. And it takes a while to do this. It takes a while to heat the hive up. There's a plate that goes in the bottom and produces the heat, and there's a thermocouple you insert between the two brood boxes, and it brings the temperature up to 106 degrees and then holds it for 2.5 hours. You put an insulated cover on and tape up all the seams in the hive. So I additionally installed additional thermocouples that I could read, because that one doesn't tell what the device didn't tell what the actual temperature was. So I confirmed that it did get up to 106 degrees and hold that 106 degrees, sometimes up to 107 degrees, up towards the top of the hive. And then after checking the first couple of them, I installed a thermocouple, a thermistor, clear down to the midrib of the brood combs underneath the sealed brood, and confirmed, yes, that there's very little buffering effect or insulating effect here, that right at the midrib of these combs, you get up to 106 degrees in those cells. So anything in those cells will also be exposed to that high temperature. Then I did something many people don't do. I went out there after 24 hours and I dissected the brood cells and pulled out propupae and pupae of various ages. And you could very quickly see whether the mites were killed. You can see these were dead. They're on their back here. Or whether their mites are healthy and running away from you. Here's a picture right here of after I went through and dissected a brood right here. And I looked for both drone brood and worker brood. And in this picture, every one of these mites, except for I think one, is actively moving about. There was very little kill of that. So here's some actual data. So these are 4 different hives, thermal 1, thermal 2, 3, and 4. And when I went back after either 24 hours or 48 hours, so this one I did both a 24-hour test and a 48-hour test, and looked in the dissected drone brood until I found a number of mites, enough to see a difference. And this was the first one. This is the unusual one. This drone brood was right along the bottom bar of the, these are all were taken from the upper brood chamber, but this is right in the bottom bar of the upper brood chamber, next to the little airspace between the 2 chambers. And this is the first one I looked at. Man, I said, wow, this is incredible. We get only 2 live mites and 16 of them are dead. I said, wow, this really works. And then I moved a couple inches away up to the worker brood in the same hive, and I had 22 live mites and only 2 dead mites. Well, that was really surprising to me, this monstrous difference between the drone and the worker. So I didn't know whether it was an effect of drone or worker, or whether it was just due to placement on the combs. The next one I looked again, and the next one, the drone brood was a little higher up on the comb, in the middle of the comb, in the middle of the upper box. And in that case, 34 live mice, only 3 dead ones. And I dissected 50 worker cells and didn't find a single mite. All the mites were in the drone cells of that one. Then I left some of this brood, went back after 48 hours, see if these live mites would be dying. And there wasn't a whole lot of brood left, but what I found was 12 live mites, only 4 dead ones. So then I went back again, the next one to look at, and again, most of the mites in the drone brood were alive, and most of the mites in the worker brood were alive. So and this is confirmed they were exposed to that temperature with that thermistor. So I am not clear about the mite kill. So this is now our alcohol wash counts at day 0, before I applied the thermal treatment, after 24 hours, at day 15, at day 31, and one of them I have it for day 42. And you can see, yeah, we got some mite reduction, but certainly not a long-term mite reduction. Very different from Mike's data. And I have no idea why. I've asked him, could it be the humidity or what? So he's going to check some more. So I wasn't too impressed with the mite control, especially with the amount of cost and time involved in the thermal treatment. And then after listening to Allison speak yesterday, this is a copy of her graph from yesterday of what happens with the queens and the sperm viability in the queens dropping off at high temperatures. So after the presentation yesterday, I said, wow, I'm going to run out and take a look at those 4 hives. And I opened them up and checked them for queen rightness. And the first one had a big cluster of bees, but no sign of any brood at all. So they had a cluster, so I'm not sure if they were queenless, but there was 0 brood. The next hive, 0 brood. The next hive, 0 brood. The next hive, 0 brood also. So out of the 4 hives that I treated, when I went to, these were all 42 days after treatment. This was 85. Not a one of them had a sign of a queen in it. So this was a little surprising for me. So if anybody else in this group has done thermal treatment, I would love to hear of your results from that. Another one, we talked yesterday about oxalic acid vaporization, but how efficacious it actually is. And it is not approved for use when the honey supers are on. It's not even approved for use during the summer at all, only for spring and fall. So I'm a little surprised that some agents are actually suggesting using this for summer treatment, because that's illegal to do it at that time. I did a little bit of data on this, checking with multiple vaporizations. Each one of these triangles is a vaporization, roughly 10 days apart over time. And this is the alcohol wash counts of the mite infestation of these 2 hives. And you can see I was able to take it down after 9 vaporizations in total. So that'd be a total of 18 grams of oxalic acid applied to these hives. But it took about 1, 2, 3, 4, 5, about 6 vaporizations in a row to bring the mite level down substantially. So I would not expect any rapid response in the mite drop with oxalic vaporization. So let's get now to what is actually approved. There's only 2 treatments approved while there's honey on the hive. This is hops beta acids and formic acid. These are the 2 registered treatments. HopGuard has a new one out that claims that it has increased efficacy and controlled release for 14 days. That was a problem, that the first ones did not have a controlled release. And yesterday, Ramesh said, oh, I hope that the new one's less messy. And Ramesh, no, the new one is no less messy. It's still got that sticky stuff on it, but it's easy to put on with gloves. The other one is this Formic Pro, which is David's been working on this for years. I did some of the preliminary testing also. And this one, I'll tell you right now, is way more applicator friendly, mainly because it has a longer shelf life. When you open up the Mite with quick strips, you got a blast of formic acid, enough to cause possible harm to the applicator. With these Formic Pro, there's very little of the initial blast of formic acid coming out. I did some testing of this. So these are Mite with quick strips, some nearing the expiration date. And these are 2 Formic Pro pads. This is the loss at the end of 1 day of the loss in weight from them. And as you can see, at each day, they're almost identical. They both contain roughly 100 grams. And this is not on the label. That always surprised me. It doesn't show. You have to actually do this to figure it out. They each contain 100 grams of pure formic acid, not diluted, but calculation, pure formic acid. And I have day by day the same release rate. I need to go back and do this again with these and compare it for over the first 24 hours. And I've done that with Max. There's a big spike really early in the first 24 hours. My guess is that the Formic Pro doesn't have quite that spike in the first 24 hours, but by the end of the 24 hours, it releases the same amount. But that initial lack of release or slower release may help with queen issues. Now, there are two things here with the HopGuard. Can be applied anytime, but its efficacy increases when there is less brood present. Now, this is the flip side of saying the efficacy decreases when there is brood present. And I was doing a summer trial with brood present. The Formic Pro, there's limitation. They don't recommend it using it over 85 degrees. And this was a summer treatment, so it was well over 85 degrees, as you will see. Then what I was really interested in is comparing those two treatments to this experimental treatment, this extended release oxalic acid on cellulose matrix. Last few years, I've been using shop towels, blue shop towels. This year, I tried it with the Swedish cellulose sponge cloths, and bought a few thousand of them, and we cut them into pieces and made a whole bunch of strips to try these out. Now, let me tell you right now, this is not a legal method in any way. I get a pesticide research authorization every year, updated, and so I can legally do this, but I'm not suggesting anybody else use this method because it's not yet approved by the EPA. Set this up, 263 hives, 7 different yards at different elevations. I decided to run it for 44 days duration so that the treatments that take a while could take effect, so notably the extended release oxalic acid, but would still be short enough to show the short-term treatments like the formic acid if they kept mite levels down for the 44 days. Temperatures were high. I'll show you a graph later. Now, because I wanted to see if the formic acid affected queens, I intentionally ran this with second-year queens. And we had a really terrible spring for the bees with rain. And these colonies, which normally I had planned on thinking they'd be up in that 15 to 20 frame strength, they were only about 8 to 10 frame strength. And many of them, we added a second brood chamber of either drawn comb or foundation just at the beginning of the trial. So this may not apply to big, huge honey producing colonies. I got it intentionally. I started with a wide range of mite levels. There was a weak nectar flow on. We fed some sugar syrup, and as it turned out, you'll see some did make some honey. Now, the reason I wanted to have high mite levels to start with in many of the colonies, let's just say you had an initial mite wash count of 3 mites. Well, a single mite represents 33% of that count. It's really hard to do statistics on efficacy if a single mite represents 33% of the count, because you're going to have this margin of error in any kind of mite wash. So it's much better if you start off with 35 mites and you go down to 1 mite. Well, now you can say something was very efficacious, as opposed to going from 3 mites to 1 mite, which really don't tell you that much. So I did have a lot of high mite colonies. And I also showed whether you could save these colonies with these treatments. The treatments I tested was the oxaloglycerin, 1 strip containing 25 grams of oxalic acid. Now, let me tell you right now, we're going to look back at this at the end. Because the strip contained it does not mean that 25 grams were released to the bees. Then I put in 2 strips, oxalic shop towels. I added this as an afterthought, so there's not a big N number of these. HopGuard, 1 strip per 5 frames of bees. So the colonies either got 2 to 3 strips of HopGuard. Formic Pro, 1 strip repeated at 10 days, or 2 strips at the initial treatment, not repeated. And then we had some controls. Now for the controls, I only chose colonies that had starting mite counts between 10 and 20 mites. Anything less than 10, I wasn't sure whether a colony might be mite resistant. And anything over 20, by the end of the trial, they might have a too high mite count and collapse. So the controls were a moderate range mite counts. And I put in the 2 of these shop towels containing 18 grams of oxalic acid, as I've done in my trial last year. And this is just a dummy hive, just to show you. There's a 1 Formic Pro strip, and you can see the relative size of these. There's a 25 gram sponge, so we put either 1 or 2 of these into a hive. And here I am applying HopGuard right here. And yes, it is still sticky. And I find these kitchen tongs are very handy for applying these pad treatments. I also found that for applying at least the hop guard, these cheap polyethylene gloves, disposable, are really nice. Now, according to the label, you need to use much heavier nitrile or rubber gloves for the formic acid. In reality, these are really handy out in the field. This is a typical test yard, just starting to dry up, getting near the end of blackberry bloom. And then it surprised us. We thought the flow was all over, and then things started happening later on. And we got some bloom, and especially yellow star thistle, which is not in this slide. We started making some honey on these hives. Okay, so at the end, you had data sheets. Everything, the treatments, all randomly assigned out here, semi-randomly assigned. And I'll show this in the write-up. You read it when I publish it. Hive number. This is just for the first 23 hives. There were 263 hives of this data with the starting mite count, ending mite count. Some got midterm mite counts, and whether there were very many bees in the upper box or not. Okay, I did, for each of the 7 yards, go out at midpoint and take alcohol washes just to see how the mite counts were doing in representative colonies. So I intentionally chose colonies that did have a good population of bees that I thought were actually representative. So this one here is for the controls, and you can see not much mite increase in the first half of the trial, first month, but then considerable mite increase, or not considerable, a modest mite increase afterwards. And most all the colonies pretty dang consistent that I checked it. And you're always going to find these outliers that are different. Formic Pro strips, I treated at this date and at this date here. And you can see by the end. Now, these lines don't mean this is the actual mite count. These are just connecting the points, the data points, so you can see, keep track of them. But you can see that the mite counts went down in most of the colonies substantially to a very low level. We're talking, this is the 0 to 10 mites here. And then held pretty good right there. Formic Pro 2 strips applied on the same date, same thing. Mite counts went down, and most of them stayed down pretty well on this one. Hop Guard 3, good mite knockdown, but the label was not clear about repeated application in the summer. I wish I would have talked to the company. Since this point, I've spoken with Fabiana, who works for the company and has been involved in for many years in development of Hop Guard. And for clarification, she says, yes, you could have treated multiple treatments during the summer. And in retrospect, I see that I should have, because we got a fairly good mite knockdown, but I could have put in 2 more treatments of the Hop Guard here, and we would have gotten much better results. Okay, shop towels, and as expected, you don't see much with the oxalic glycerin for the first month, and then it starts to go down. So kind of similar to what I've seen before. 125 gram oxalic sponge, decent knockdown on these few that I saw here. And the 2 sponges, much better. We took it down quite a bit. Now, I'm going to talk about this later. I don't think it's the difference between the total dose. It's the surface area. This was 2 sponges of surface area. The other one was 1 sponge. And that seems to be more important than the actual dose. Okay, so I'm going to share the results for all the hives right now. And I'm going to show it in histograms. So what you're going to see is each pair of columns represents the 2 counts from one hive. The blue column is the starting mite count, and the red column is the ending mite count. And then down here, the letters are the yard name. So this was my Loma Rica yard, then Old Colfax yard. And so you can tell if there was a yard effect also. And then for all of these, I made the median so that half of the values were above this point and half of the mite counts were below that point. So this would be your median value. So for each one of these, the thing you want to look at here is if you see a lot of blue, meaning that the mite counts went down, that's a good thing. If you see a lot of red, that means that the mite counts went up, and that's a bad thing. So let's go through them here. So first we can look at the controls, and you can see across the board the mite counts went up. And again, they all started in this fairly low range. With a group median, they went up about 1.5 times from the starting count. Formic Pro with 2 strips. See a lot more blue here. They went up pretty well. Of the median value, we only ended up with 17% of the starting count across the board. Now this is where breaking this out by yard is useful. Look over here. This is 1 yard here. All the ones that they went up all happened in 1 yard here. And I have no idea what happened in this yard. But by breaking this down yard by yard, rather than just giving you a box plot, allows you to learn a lot more from this data. So if you were a beekeeper in any of these yards, you would have said, wow, Formic Pro, 1 strip repeated, gave me incredible results. If you were the beekeeper in this yard, you say, oh, it didn't work worth a damn. So you have to be very careful looking at these results right here. Steve, I got a question for you. Are you there, Steve? No, you're not there.
No, of course I'm here.
Oh, okay.
I'm just trying to
So
be.
here's a question for you, Steve.
Okay.
We have a blue column right here, and I don't see any red. What does that mean the final mite count was?
0? No,
You got it.
that's 0.
Okay, so guys, if you see a blue column without a red after it, that means the mite count was 0 at the end, and that's what I like to see, a lot of zeros. Okay, Formic Pro, 1 strip. Formic Pro, 2 strips. Okay, and ending median count down to 20% of the starting count. Good overall. A couple of wild outliers right here. So I don't know whether after the 2 strips they robbed out a colony that had high mite levels, whether they were a mite magnet colony, and there are mite magnet colonies that just bring in mites from elsewhere. But this was in 2 separate yards right here. So again, we will always see these outliers for any kind of treatment, even for the apivar treatment. There's outliers. And the Formic clearly killed the mites. When I went back to put the second strip in, you can see the dead mites on top of the first strip here. The other thing about formic acid, and I can't remember who was talking yesterday about formic acid and being stressful for the colonies. Oh yeah, it is stressful for the colony, especially in hot weather. But the thing that I've noticed year after year, and others have noticed this too, is after a formic acid treatment, it gives the brood a fresh start, and you wind up just having these spectacular, beautiful brood patterns. Well, by August, our brood patterns do not look very good, but they look like springtime brood patterns after the formic treatment. So this is the double strip treatment right here. Stressful on the bees, but boy, the brood, after the formic kills all the eggs, knocks out a bunch of the first and second instar larvae. So you lose a total of about 5 days worth of brood starting. It doesn't hurt the older brood, but just brood starting. So this is like a 5-day break. But boy, the brood almost always comes back looking way better after a formic treatment. And let's say these are frames put in this year. These are frames of foundation, a full box foundation putting on top of a hive. And you notice these bees, after the formic treatment, were able to not only recover, but draw out the foundation on all 10 of these frames and put on a decent little honey crop on that. So we did see that the colonies can recover very well from that formic blast a little bit earlier in the season. Then here's the question: what about the queens? These were all second-year queens. They were all older queens, and here is the recommendations from non-apiary products, and they show that you do not want to apply it above 85 degrees. This is the temperature record for what we did in this trial. And what you can see is that the first treatment was applied with temperatures, well, this red line is the 85-degree line. So applied well above the red line temperatures. The second one, a little bit above that. So we really stress these colonies. And depending on the arcs, we put all the treatments on the same day. So some were put on right at the peak of the heat of the day, and you'll see the results. We saw the results of this, or you will see it in a minute. That was really stressful on the queens. Those that were put on a little bit later in the day were not quite so stressful. But you can see the bees do come out and beard up on the colonies and are definitely stressed by these treatments. They want to fan it out. Now I have done experiments where I have caged the queen right below formic acid strips, and I have found it doesn't necessarily, I don't see any indication that queens are more susceptible to formic acid than the adult bees, because you can kill the workers, see the dead workers, oh, this is upside down, dead workers in the cage right here, despite the fact that the queen in here survived. I don't see her, but she survived here. So the formic acid, I'm not sure if it's the bees that kill the queen or the acid that has a direct effect. So here's the results on the queen rearing, or the queen survival. So for the control colonies, now these were all second-year queens. So in August, there was already supersedure going on in a number of the hives, and sometimes it was not successful. Okay, independent of treatment. So in the controls, there were 39 controls. 2 of them went queenless during the trial, 5% of them. Formic Pro with the 1 strip, 28 of those, 1 was queenless at the end of the trial. That's only 4%, a lower rate of queen loss than in the control group. Now, I'm not saying they have the same queen. A number of these clearly replaced their queen. I don't know whether it's due to treatment or due to supersedure, but they replaced. So I went back at 20 days and then checked back a couple times afterwards to see if they had fresh egg laying from a queen. So I counted them as queenless if they did not have a new queen by the end of the trial. So Formic Pro, low. Now for 6 of the yards that we put Formic Pro on with the 2 strips, again, pretty low rate of queen loss right here. And but for 1 yard where we put them on in extreme heat, 100% queen loss of those 5 double treated colonies. So if you're going to put the Formic Pro on a hot day, I would do it at dusk when it's cooling down for the bees. Hop guard, no queen loss at all. Oxalic, the different 3 oxalic treatments, a moderate rate of queen loss. And again, this is probably right around the baseline with the low mite controls. Okay. Hey, Steve, what time do I have till?
You have another 7 minutes, Randy, and then there's the break. So you could probably go over a bit.
Great. Okay. Okay. Hop guard. Oops. I'm not going to even show you the results of hop guard because it was inadequate. Now I'll repeat it next year and do multiple treatments. Oxalic glycerin towels overall decent, down 38% of the starting mite count. 1 oxalic acid sponge, not that impressive, but look at this. Look at some of these very high starting mite counts up in the 60s going down to 0. Another one going down to 0 right there. 2 oxalic acid sponges, much better, the best of anybody, median reduction to only 10% of the starting count, with a lot of them going down to 0s. When they count overall efficacy, there's 2 ways of doing it. By the sums of all the mite counts of all the hives in the group, add them all up, or by the median values. And sometimes that makes a difference, but I'm going to blast through this fairly quickly. But if you look up all of them, the best efficacy we got was with the 2 oxalic acid sponges. Okay. Now, the other thing is, even with that, what seemed to be a high dose, the brood still looked beautiful in these colonies afterwards. Okay. Now, some of them I went on, I said, well, it didn't work very well. So what would happen if I went for 72 days? And so we ended the trial here, but some of these hives I looked back at, and you can see with the oxalic acid, especially with the 50-gram sponges, the 2 sponges, those mite counts just kept going down even at 72 days. And they will continue, based on other data, to go down farther than that. Now, we did have also 3 yards of bees that we had up at 6,500 feet up in these wet meadows. And they put on a good honey crop. They were much stronger colonies, reared a lot of drones, so lots of chance of mite increase due to the drone rearing. But there were no other hives in the surrounding landscape for mite drift. So this was interesting to me. When we brought them back, we gave them an alcohol wash to see what happened. And they were only given either a 25 gram or a 50 gram dose, depending on their starting mite level up there. So this is the first one, and we can see pretty good mite control across the board for this yard. But for the other 2 yards, when we were done doing these alcohol washes, Eric was running the agitator. I said, Eric, how are we doing here? And he goes, Dad, I've never seen so many zeros in a row. Look at all these zeros here. So these were colonies, and even these ones only 25 grams, single sponge put up there, 77 days. These sky-high mite counts, these are 50 mites in the alcohol wash here counts. All these colonies go down to 0. Extremely, when they didn't have bees around drifting mites back into them, very efficacious. Then we had running a number of other controlled trials, and we put small doses in, either a little 12.5 gram strip over these nukes when we started them, or the 12.5 gram here. So this is only a quarter of one of those sponges rather than 1 or 2 half sponges. And we laid these across the top bars. And this is for September right here. We just took some more at the end of the month, and it's similar for these. That small amount just kept the mite count, took the mite count down and kept it down for the entire season. A very tiny dose applied in June did incredible mite control, but this was not a formal trial. There's no controls here, but it's a lot of hives. The question is then, how much of that dose was actually released from the sponges? So this morning, I went out and I had salvaged a bunch of the used sponges from these colonies, and I've been wanting to get these, so I thought you'd like to see the information. So I went out and I weighed a bunch of them this morning to see how much oxalic acid was actually lost from the sponge and made it onto the bees. And what you can see, only a few grams, anywhere from maybe 2 to 5 grams in total went out. So even if we put a bunch on, this tiny amount of oxalic acid over a period of 70 days is all you need for very effective mite control. This is mind-blowing to me. My conclusion is it's not about how much oxalic acid is on the sponge, it's about how much surface area there is and how much glycerin there is. The higher the glycerin content, the more rapidly the oxalic acid goes to the bees, to the point where if you use too high glycerin content, you can hurt the bees, get adverse effects. So this is very interesting stuff. We still have some questions to answer. Why does oxalic glycerin not work as well, or why did it not work as well in some Georgia trials by Jennifer Berry and Jeff Williams? Not sure about that, but maybe high humidity may have an effect. I'm not maybe surprised. Is there a better delivery matrix than the cellulose sponges or the shop towels? I am currently testing out a number of different delivery matrices, and my experiments next year will use these different delivery matrices. Some of these are much cheaper, some are more easy to remove. So I'm weighing these now and seeing how much oxalic acid goes out onto the bees. The other thing I need to do, follow up, I've developed a titration method where I can put a liquid as water in a test tube, calibrate it to this color right here, and then drop a bee in, and the color immediately changes back to this end. That means there was acid on that bee. Then I can put in a titrant drop by drop and figure out how many micrograms that's a millionth of a gram of oxalic acid are on that bee's body. I drop it in. I just got a micropipette to do this more accurately. And when I get back to that starting color, then by how much you added to get there, it tells you how many micrograms of oxalic acid were on the bee's body. I've done this some with the oxalic vaporization, and I could not find oxalic acid. Oxalic acid dribble, very easy, to see that on the bees. So I want to start doing this. There's not enough hours in the day for me, but this has been on my desk all summer to get out there and do this. Anyway, this treatment, very quick, safe, easy to apply. We carry baking soda, 10 heaping tablespoons per gallon. anytime we work with formic or oxalic acid, we always carry this in the vehicle. 10 heaping tablespoons per gallon. It takes a lot to neutralize it quickly. And then when you pour this over your hive tool or your tongs or your gloves or hands, you'll see the bubbling and it'll immediately neutralize any acid on your skin. This is not approved, experimental only, but I'll tell you right now, this may be a game changer for Varroa management for us. I'm incredibly impressed by this. And wow, close to being on time, huh, Steve?
Yeah, good job. Good job, Randy. Hey, I'll tell you what, for those that need to, go right ahead and start the break. We have a 30-minute break before we come back. But I think, Randy, if you're willing to stay around, we could take questions here if we have some. Okay, we have two of them here. One of them is a person from Walla Walla named Stu. Can you speak specifically about any considerations when applying Formic Pro above the recommended temperature range? Thanks. I guess any tricks on that?
I would do it late in the day when the colony is going to be cooling down. And the one strip repeated at 10 days was pretty gentle as far as queen loss. If you're going to do the two strips, you might want to put one in one day and the second one in the second day, so you don't get that initial blast. As you can see from that graph, the first day you get the big blast of formic release. So you're just trying to avoid that huge blast.
Okay.
Although that blast is what really gets the mites too. So it's a trade-off. I mean, if you use a flash treatment, which is not approved, you can kill all the mites in the hive, but you're going to kill half your queens also.
Right. Here's the next question, an anonymous attendee.
Oh.
How did you choose the frames to sample mites from, and did you change frames during the summer?
Anonymous must not have been here yesterday when I gave my presentation of how I choose my frames. So that's recorded, right, Steve?
Yes, it is. So
great. Anonymous can look at the recording yesterday.
Yes. So look at Randy's earlier talk, but can you give a quick answer?
Essentially, we always choose to frame from the upper brood chamber to the side of the brood nest, but not containing brood. So the first frame outside the brood nest in the upper chamber.
There we go. Okay. I know you're going to have to be careful on answering this because, of course, this is your experimental design. Yeah. But what is the formula for mixing oxalic acid and glycerin to apply to a shop towel if one were seeking one of those permits?
I do collaborate with a number of researchers who, and this is worldwide. I get emails constantly. So I'm going to be publishing this article in ABJ, writing all this stuff. Actually, it's already in press right now. And for the benefit of researchers who have a permit to use it, I publish my materials and methods of how I prepared the towels.
Excellent.
Okay.
So that's the source. Paul writes, have you done tests with multiple up to 4 honey supers on the hive?
No, I wish I lived somewhere where we could put our bees could make 4 supers of honey. I do not live in that environment, guys. So no, I have not. So take everything with a grain of salt. And I encourage people to apply for pesticide research permits in your home state so we can have more of us working on this. I've heard from a number of them, it's hard to get depending on the state, but if we can legally do this, that'd be fantastic. And even if you illegally do it, I'd be happy to hear your results.
especially from anonymous. Anyway, yes. Randy, here's another one from Jason. Why did you choose 10 days for vaporization treatments versus a shorter frequency to catch the mites as they emerge, like 3 to 5 days over a 20, 25-day period?
Oh, because I had done modeling. I published it. It's on my website. Where I've done mathematical modeling. I tweaked my Varroa model, so instead of calculating at every 15 days, it was a 1-day model. So it showed how many mites came out of the brood each day, how many went into the brood each day, how many would be phoretic exposed each day, and I ran simulations to see what the optimal treatment timing was. So if you go to my website and read that paper, you'll understand my reasoning.
Okay. A question from Michael. Are you mixing the sponge in the same manner as the shop towels?
Yeah, very, very similar. What we found is the Argentine formulation, which is 2 milliliters of glycerin to 1 gram of oxalic acid. And this is the Aluin cap formulation, which is registered. I find that that I get too rapid transmission of the oxalic acid to the bees, and you can stress your colonies with that and see some brood damage. It's also, they're very messy and more hazardous to handle because they're very drippy, wet with glycerin. What we prefer is the 1-to-1 by weight, 1 gram of oxalic acid to 1 gram of glycerin. And what that does, unfortunately, it has to be heated. The other one can be done cold, prepared cold. I'm right in the middle of it with EPA and USDA. EPA does not want me to register, or USDA to register anything that involves heating. So I have tested it out now, and you can actually mix this cold. It takes 24 hours to dissolve it, but you can mix it cold for the 2-to-1 formula. The 1-to-1 you have to heat up, and then as soon as it starts to cool, the oxalic acid starts to crystallize out and makes a kind of a more firm towel that doesn't get on all the surfaces. Much easier to handle, much safer to handle, and that's the one that we prefer, and it gives us better results in the hive. You don't get the adverse effects on the bees, and you get this very long. What happens is the small amount of glycerin in that absorbs the moisture from the air inside the hive, and it hydrates. Glycerin is a humectant. That then allows some of the oxalic acid to dissolve into that attracted water and then get onto the bees, and it does it at a very slow, controlled rate. So I prefer that 1-to-1 weight-to-weight ratio myself.
Okay, so that looks like all we have in the Q&A section, and let me just check over here in the chat side if I can. Don't seem to be able to actually use it, so since I can't see it, it's not there, right?
Yeah.
There's